show that limit n tends to infinity 1 divided by n plus 1 is equal to 0. That is, show that the sequence 1 divided by n plus 1 is converges to what? 0. Converges to 0. So now we know that for any given sequence xn, we say that xn is converges to L if for every epsilon greater than 0, if there exists a positive integer m such that the distance between sequence and limit is less than epsilon for every n greater than or equal to m, then we can say that the sequence xn is converges to L. Now given xn is equal to 1 divided by n plus 1, this is given, L is equal to 0 and epsilon greater than 0 be any real number, then consider the term xn minus L, which is equal to mod of 1 divided by n plus 1 minus 0, which is equal to mod of 1 divided by n plus 1. Now since n plus 1 is a positive integer, we can write the value of absolute value of 1 upon n plus 1 as n plus 1. Again, now since n plus 1 is greater than n, from this we can write 1 divided by n plus 1 is less than 1 by n, and therefore we can write this term as is less than 1 by n. Okay, so xn minus L is less than epsilon. This is possible if 1 divided by n plus 1 is less than epsilon, which is possible if 1 by n is less than epsilon. Since 1 upon n plus 1 is less than 1 by n, and which is less than epsilon, so if 1 by n is less than epsilon, then obviously 1 divided by n plus 1 is also less than epsilon. That is, if we know that if a less than b less than c, if b less than c, then a is also less than c. So if 1 by n is less than epsilon, then it is then 1 divided by n plus 1 is also less than epsilon. But now since 1 divided by n is less than epsilon implies n is greater than 1 by epsilon, and therefore if we select any positive integer m, if we select a positive integer m which is greater than 1 by epsilon, then the distance between the sequence and limit is less than epsilon for every n greater than or equal to m, and m is a positive integer greater than 1 by epsilon, and therefore now we can find such a m for any epsilon greater than 0, and therefore we can say that the sequence 1 upon n plus 1 converges to what? 0. In particular, if we take here epsilon is equal to 0.1, then the distance between the sequence and limit is less than 0.1 if we select n greater than or equal to m, which is greater than 1 divided by 0.1, that is m greater than or equal to 10. So if we select any positive integer m greater than or equal to 10, then greater than 10, sorry, not greater than or equal to 10, since 1 upon 1 divided by 0.1 is what? 10. So if we select any positive integer m which is greater than 10, then the distance between the limit sequence and limit is less than 0.1 for every n greater than or equal to say 11. and therefore this is true for particular value of epsilon is equal to zero point 0.1. We are able to find a positive integer m such that the distance is less than zero point 0.1. Similarly, if we take any epsilon, take one more epsilon, say epsilon is equal to say 0.5, then what is here m is equal to, we want to select m which is a positive integer greater than zero point 0.5. So select here m is greater than 2. So we can select a positive integer m which is greater than or equal to 3. Then the distance between this sequence and each term of the sequence and limit is less than 0 0.5 for every n greater than or equal to what, greater than or equal to 3. And now if we select if we take any epsilon greater than 0, we are able to find a positive integer m such that the distance between xn sequence and limit is less than epsilon for every n greater than or equal to m. And therefore we can, from this we can conclude that this sequence 1 upon n plus 1 is converges to 0, that is limit n tends to infinity 1 upon n plus 1 is equal to what, 0.